All right, joining me now is Dr. Michelle Moyer. Hey, Michelle, thanks for taking the time to join me today on the Vineyard Underground podcast.
Hey, Fritz, super happy to be here. I cannot wait.
All right, well, let's dig in. I'm excited to get to our topic of modern powdery mildew management. But before we do, could you tell our audience a little bit more about yourself, your research, and how you got interested in the field of viticulture and plant pathology?
Yeah. So let's start with the last one, the plant pathology. So Fritz, as you know, I am a plant pathologist by training, or as my horticulture friends and viticulture friends like to refer to me as a recovering plant pathologist. So yeah, I do have a background in plant pathology, but I'm currently the viticulture extension specialist here at Washington State University. But as probably similar to what you do, a lot of my time is spent helping folks through or understanding their disease and pest pressures in their vineyard, right? That's a lot of viticulture is get the fruit healthy first, and then we can focus on all the fun stuff later. So my background is from the Midwest, originally from Wisconsin. So occasionally we'll get that long O coming out in this podcast. So the peeps listening in the Midwest can feel at home with that. So I grew up in the Midwest in an agricultural type background, actually horticulture, ornamental horticulture background. Did the school stuff, did the grad school stuff, landed at Cornell University where I worked on grape powdery mildew. So lots of practical exposure to grape disease management in New York. But by doing that degree, I really wanted to do extension, right? So I really enjoy working kind of the hands-on applied in the field. I love research, I love science, but I really love the practical side of things. And that's what brought me out to Washington State right after graduate school. And I've been here ever since and talk about a total shift in disease pressure and practices. And it's been really fantastic to kind of see viticulture and pest management and how the practices are extremely different in the two locations, but the principles are identical. So it's a fun way to kind of tie everything together, which I hope we can cover today as we start talking about powdery mildew.
It could just be on a shady end of your vineyard near the trees
Exactly.
or randomly. So I want to dig more into the oncogenic responses. We get deeper into things.
Absolutely.
And I'm sure you do too. But what about grape varieties?
Yeah. So that other grape varieties, locations, et cetera. So Vitis vinifera, right? Super susceptible. And there are some people who'll say, "Oh, but my Cab Franc doesn't get it, but my Chardonnay does." And I think it's really, when we're dealing with vinifera, it's really not about what variety is more resistant or not. It's how we're growing them, right? So powdery mildew, because it grows on the surface, it likes healthy, vigorous plant tissue. What that essentially means is it doesn't like super sunny and hot conditions. It doesn't like super dry conditions. If you have big canopies, shady canopies, lots of irrigation, lots of canopy transpiration, so it's super humid inside the canopy, all those things will increase your risk for mildew. And we tend to farm white grape varieties with bigger canopies, higher yield. At least in dry climates like Washington, we farm our reds where we're doing a little more deficit irrigation, so the plants are a little bit stressed out. The canopies are smaller. There's more sunlight. So they're at equal risk. They're both equally susceptible, but the risk of getting infection is pretty different. Now, when we start to go to all the cool hybrids that are out there, that's all over the board where there's actual genetic resistance to powdery mildew of varying degrees. And then some varieties like Vitis labrusca, the juice grapes, some of the muscadine grape varieties, those actually have a really high level of natural resistance to powdery mildew, which means they can still get some infection, but the infection doesn't really take over the plant like it can with Vitis vinifera.
You worked with Wayne Wilcox, our good friend and mentor, and he was your graduate advisor, correct?
Or one of them, yeah. He was on my committee. Yeah.
One of them. Okay, on your committee. And they did some work on UV. So I think it'd be great if you could just touch on what sunlight is actually doing as its component, because temperature, airflow, drying out the canopy, reducing relative humidity in the canopy, mitigating the effects of the transpiration in a heavy canopy. But what are we getting out of direct sunlight?
Right. So there's two things with direct sunlight, right? There's UV, UVA and UVB. And UVB, just like humans, right? It can cause skin cancer to people, and it can cause some DNA damage and powdery mildew as well. And we're going to talk a little bit more about other UVs, probably a little bit later in this segment. But UV in general can actually damage the DNA of powdery mildew. And if it's growing entirely on the surface, it's very exposed. It has no way of protecting itself, right, from direct UV damage. The second, though, is radiant heat, right? So direct sunlight comes with heat. It's really hard to separate UVB and heat when we're doing experiments. And that's what Wayne and his graduate student, Dr. Craig Austin, were working on, was try to figure out, is it the UV component or is it the heat component? But when you have direct sunlight on a leaf surface, that surface can actually heat up to a temperature that is higher than the ambient air temperature, right? Especially if that plant is a little water stressed or if they're not actively irrigating, it can't actually transpirationally cool. And so powdery mildew is super sensitive to those really high temperatures. And we see that, and we might talk about it a little bit later, but there's a lot of models that tell you essentially when to stop spraying when air temperatures get really high, because typically with really high air temperatures, you also have sun, which also means the surface temperature is even higher on a plant. So it's a combination. When we talk about allowing sunlight to penetrate the canopy, it's a combination of that direct UV damage and surface heating the surface so it's at a temperature that's uninhabitable for the powdery mildew fungus.
It's almost like the zombie apocalypse kind of theory. The virus comes along, it takes out 99% of the population, and there's few mutants that manage to live with the virus, and then they reproduce, create a whole new resistant society, right? And
Absolutely.
then your virus or your spray no longer works. But it's even worse because you only need one individual to asexually reproduce. You need like two,
Right.
to mate. So
Yeah.
this is even scarier. Okay, so let's go into a little bit about that, because I wanted to talk with you about what research is telling us about preventing resistance and how is frame, or it's also referred to as frame networks, taking action to help with this problem. Because like you said, we have a limited number of products and formulations and modes of action that are in the toolkit for preventing or treating powdery mildew. So if we misuse them and create resistance issues and we no longer could use 20% of those, 30% of those products, it really limits our program and our strategies. So how is Frame doing that? Tell us about first of all, what is Frame and what is your involvement?
Right. So FRAME is an acronym because scientists can't live without acronyms, right? It's our bread and butter. So FRAME stands for Fungicide Resistance Assessment, Mitigation, and Extension, right? And it's a group of scientists that got together and put together a federally funded grant to work on fungicide resistance and grape powdery mildew specifically. And so we did this project between 2018 and 2023. Had a break, and now we actually just got funded again to do another 4 years to kind of expand into downy mildew and botrytis and work on a bunch of different fungicide groups because the first iteration of the project really focused on frac-11 or strobilurine fungicides.
Mm-hmm.
So to your first question, how do we prevent resistance? And I think one thing that a lot of us are probably finally grappling with or really starting to understand is when we have products that are so site-specific, like a lot of these frac groups are, which are by nature, they're designed to do that so they don't impact non-target organisms, right? So
Yeah, by site, we're talking not about the grower site, but by
no,
the
but yeah, the
they're
fungal.
attached to like
What they do in the fungus, exactly.
inside
Right.
the actual cellular level, right?
Right. Yeah. So they're designing chemistries that it's like targeted chemistries. It only kills these certain things. And so it's not killing everything in your vineyard, right? And that's a good thing, right? We don't want fungicides impacting beneficial insects, et cetera. But when they do that, when something is super site specific, the potential risk for resistance to that very singular site is much higher. It's much easier for powdery mildew to overcome somebody trying to, prick it with a little needle, right? They can dodge that needle versus if you come at it like whack-a-mole and you just whack it over the head like sulfur does, it's really hard to overcome total body crushing.